Constant rate of change from a linear table. So in order to determine, we're going to determine what is the difference between 7 and 14, 14 and 21, 21 and 28. How do we go from 2 to 4, 4 to 6, and 6 to 8? We're going to determine if it is a linear relationship. If so, we're going to find the constant rate of change and apply it to an equation. So to go from 7 to 14 is an increase of 7. To go from 14 to 21 is an increase of 7. To go from 21 to 28 is an increase of 7. So the x value has a constant rate of change of positive 7. To go from 2 to 4 is an increase of 2. 4 to 6 is an increase of 2. And 6 to 8 is also an increase of 2. So this is a linear relationship because the rate of change between the x values is constant and the rate of change between the y values is also constant. So positive 2 for the x's, positive 7 for the y's. So in order to determine what the constant rate of change is, I'm going to divide the constant rate of change of the y's over the constant rate of change of the x's. So 7 divided by 2. 7 divided by 2 is 3.5. So that means that it is 3.5 times x will give you the value of y. If I do 3.5 times 2, I'm going to get 7. If I do 3.5 times 4, I should get 14. If I do 3.5 times 6, my value should be 21. And then if I do 3.5 times 8, I should get 28. Because this was able to be applied to each one of the x values and then the y values came out accurate, we know that this is a linear relationship with the constant rate of change of 3.5 with an equation of 3.5x equals y.